All right, today we're going to do 9.1, day 2, which is simplifying radical expressions. Before we get started with the lesson, I do want to go over two problems from the homework last night that lots of people had kind of the same error on. So number 14 was root 32. I think most people think of 32 as 8 times 4, which it seemed like you guys did. So you said, okay, well, instead of 32, we can write that as 4 times 8. And then we know that the square root of 4 is 2. And so we get 2 root 8. And lots of people left their answer as this, which is not fully complete because we can still break up 8 even more. So we could rewrite 8 as 4 times 2. We know the square root of 4 is 2. So this 2 would come out to the front and it would get multiplied. So this would give us 4 root 2. Same thing on number 15. It was root 128. Okay, most of you wrote this as 16 times 8, and so you had the square root of 16 times 8. That 16 came out as a 4, and you left your answer as 4 root 8. But again, we can break up that 8 even more. 8 is 4 times 2. We know the square root of 4 is 2. Those would get multiplied to give us 8 root 2. So you want to be really careful and make sure that in your answer, when you look at the number inside the square root, that it can't be broken up anymore. So 8 is one that is often left. That's an error that's made a lot. But 8 is 4 times 2, so you can kind of keep going with that one. Okay, so in the first day's notes, we had this rule that said no radicands can contain fractions, and no radicals can appear in the denominator of a fraction. So the lesson today is going to focus on making sure that we can fix the situation if we have one of those two rules that's being broken. Okay, so the process of what we're doing here is called rationalizing the denominator. So when a radical is in the denominator of the fraction, we're going to multiply the fraction by an appropriate form of 1 to eliminate the radical form, and this is called rationalizing the denominator. So we know that 1 is equal to 1 over 1, and we can write that a lot of ways. We can write that as 5 over 5. We can write that as 7 over 7. We could write that as 70 over 70. In this case, we're going to be writing it as something like root 3 over root 3. Okay? So what we're going to be doing is we're going to be multiplying by 1, technically. So we're not really changing the value of the expression, but we're not going to do a simple 1. We're going to instead be multiplying like something like root 3 over root 3. All right, so in the first one, we have 7 over root 6. So we cannot have root 6 in the denominator. That's breaking that rule that there's a radical in the denominator. So what we're going to be doing is we're going to be multiplying by a version of 1, okay? What we want to think about is what we need to get rid of. We need to get rid of that root 6. We cannot have root 6 in the denominator. So what we're going to multiply is by root 6 over root 6. So that's our version of 1. So in the numerator, that would be 7 root 6. And then on the denominator, root 6 times root 6 is going to be root 36, which is regular 6. Okay, this would be our answer. I do want to do one more example similar to this. Say we had something like 8 over root 6. We would still multiply by root 6 over root 6, and we would get 8 root 6 over 6. Now we have two numbers outside of radicals, 8 and 6, and we can simplify that. So when we think about the fraction 8 over 6, we can divide both of those by 2 to write this as 4 over 3. And then that root 6 would stay the same. So when we're simplifying, we want to look at the numbers outside of radicals and think if that can be simplified, kind of like our normal fractions are. Okay, so we would get that as our final answer. And it's fine to have radicals in the numerator. We're not breaking any rules that way. All right, for B, we have root 3 over root 5a. So again, the thing we cannot have is that root 5a. So we need to multiply by root 5a over root 5a. In the numerator, root 3 and root 5a would become root 15a. So those numbers inside the radicals are going to get multiplied together. And then root 5a times itself would become regular 5a. Okay, when we look at 15, if we think about 15, 15 is 5 times 3. We can't take the square root of 5 or 3, which means we can't take the square root of 15. That would just stay. And we can't do the square root of a. It's not a value squared. So there's nothing more we can simplify on this one. So this would just be our answer. We have the 15a is under the radical, and this is outside a radical, so we can't simplify like that or anything. Okay, for C, we have the square root of 2x to the fourth over 3. So we can rewrite this as the square root of 2x to the fourth over root 3. Now we can take the square root of x to the fourth, and that would give us x squared. We would still have root 2 over root 3. The root 3 in the denominator is what we can't have, so we need to multiply by root 3 over root 3. That's going to give us x squared root 6. So again, we'd multiply what's inside the radicals. So 2 times 3, that gives us root 6. And then in the denominator, root 3 times root 3 is regular 3. And that would be our answer. All right, D looks a little bit more complicated. What I would recommend if you have a situation like this where there's a lot of values under a radical is see if we can simplify inside of there first. So 50 over 150, well, that simplifies to 1/3. We have an x in the numerator. Y and y to the third would simplify to y squared in the denominator. And then we have that z to the third in the numerator. Okay, so we can simplify that quite a bit. In the numerator, then, we have x z to the third over 3y squared. Well, we can take the square root of z to the third. So that would give us z. We would still have 1z under the radical. And then in the denominator, we can take the square root of y squared, which is y, and then we'd be left with root 3. Okay, the part of this that we can't have is that root 3. So that's our version of 1 that we're going to multiply by. So we would have z root 3xz over y times 3. Okay, we can probably just rewrite that as 3y. Usually we have our coefficient first. Again, these values are both outside the radical, but they can't be simplified. So this means that this would be our final answer. All right. Please make sure you're showing your work on your homework. I am replying to all your homework if you have answers wrong with which ones are wrong and kind of trying to give you an explanation of how to do that, how to do them. So please make sure if I send you those messages, it'd be really beneficial to go back and look at them to kind of help and make sure that you correct any errors that you have before moving forward. All right. Have a great weekend.